Inside the atom inside, today we will see the next information, that is the collect information. So hydrogen has three isotopes. Hydrogen has how many? Three isotopes. They have separate names, that is hydrogen, deuterium and tritium. Find out their mass numbers, collect the information about what is heavy water from internet. So first of all, we will see the protons. So here it is, hydrogen's atomic number is this and mass number is this. Okay, so we will write how many protons are there. As we know that atomic number is how much? 1, then its protons are 1 and neutrons 0, because 0 plus 1 is equals to 1, and that we are writing at this place. Okay, because it is atomic mass. Next is the another isotope of the hydrogen is, so here what will come? 1 and here it will come 0, because 0 neutrons are there. Then 1 plus 0 is the mass of what? Mass of the hydrogen, and that mass we are writing at the top of the hydrogen H, and below 1 we are writing. Now second, if you see here, you will notice that here hydrogen, but protons how many given? 1. Protons are 1, so its atomic number is 1 only. So downside we are writing 1, and 1 plus 1, this one plus this one means it is mass, so it is 2. So 1 plus 1 is 2, so mass we are writing, mass number we are writing at the head of the hydrogen. Okay, next another one is the hydrogen only, its atomic number 1, that you write here. Okay, and this is the neutron numbers, number of neutrons, and that is 2 plus 1 is equals to how much it is there? 3. So H 3 1. So note down all of you this, how to write, and this is called as a hydrogen. It is called as hydrogen, HYDROGEN. This is hydrogen, this is deuterium, and this is tritium. So this hydrogen, deuterium and tritium are the three isotopes of hydrogen. These are the three isotopes of hydrogen. Okay, so here the names are given, and just I shown you how to write its problem. Hydrogen, deuterium and tritium. So H here atomic number 1, here it is 2, H atomic number 1 and atomic mass number is 3, and here it is 1 and here it is 0. So in this way this box you have to complete. Now this is what I told you, this is hydrogen, here it is given. Second is deuterium, this is the deuterium, and third is tritium, it is here. So this is the about the hydrogen's isotopes. Like hydrogen, like carbon, yesterday we seen the carbons also isotopes here. Okay, so that these carbons isotopes are C12, C13 and C14. Same way the hydrogen's isotopes are the which? Hydrogen, deuterium and the tritium. And lastly we will see the next, that is the chlorine's isotopes. So chlorine, if you see here Cl, so if this is the atomic number, so atomic number is equal to number of protons. So here it will be 17 and here it will be 17. Okay, now upside it is how much given? 35 given. If we subtract 35 is its mass number. Okay, and mass number how much it is there? We said that mass number means protons plus neutrons is the atomic mass. Proton plus neutron is equal to atomic mass. So here this is the atomic mass is how much given? 35. Protons just we find it is 17 and neutrons we have to find. So number of neutrons is equals to 35 minus 17. So here when we subtract this both, what you will get? It's a 15 minus here, if you do the subtraction you will get here what? 18. So here it is 18 is the number of neutrons which are present in the chlorine. 35, it is the isotope of a chlorine. Now move towards the second one. Chlorine 37 is given upside, so its atomic mass is equal to how much? 37. So instead of here atomic mass 35, I will write here 37. Okay, now here what will come? 37. Atomic number is changing? No. Here it is 17 written, here also 17 written. And atomic number is same, its number of protons are also same. And 37 minus 17 is equals to, its subtraction is equal to how much? The 7 minus 7 0, and 3 minus 1 is equal to how much? 2. So 20 neutrons are present in the chlorine. Okay, so how many neutrons are present in the chlorine? 20. Chlorine 37, 20 neutrons are there, and chlorine 35 inside, 18 neutrons are present. And protons here, just I will fill the box so you will understand it. H 2 1, and here H 3 1. Okay, so all of you write down this box. If you understand it, it's very easy, and you will definitely you will understand it. Now we will move towards the next part of our lesson. Okay, and the next part of our lesson is the uses of isotopes. So what are the uses of isotopes? So see here, isotopes of some elements are radioactive. Radioactive means their nucleus is there. If this is the atom, its nucleus emits the rays, a kind of a rays, and that's why they are called as a radioactive rays. They are used in various fields such as industry, agriculture, medicine, and research field. Inside these isotopes which are radioactive that we are using. Okay, and which are those we will see. So uranium 235. Uranium 235. This uranium 235 is used for nuclear fission. Okay, for the production of electricity. By using this uranium 235, what the nuclear fission takes place inside the nuclear power point, and from that energy is produced, heat is produced, and that heat is what happens using it for the production of electricity. Some radioactive isotopes like cobalt 60, cobalt 60, it is used in the treatment of cancer. It is a fatal disease. Fatal disease means what? The person cannot be cured if he get the what? This cancer. Next it is the iodine 131. Iodine 131 is used in the treatment of goiter. This goiter, you know, no? That here neck below, what happens? The muscles, what happens? Growth takes place, unwanted. So this is called goiter. Diseases of thyroid gland. Okay, on the treatment of this, iodine 131 is using. Next, radioactive isotopes are used in the detection of the cracks or leakage underground pipes. Okay, underground pipes are there, they are underground, it is there, so it is impossible to find out its cracks. So for that, radioactive isotopes are used for the detection. And which is that radioactive substance? That is sodium 24. Next, it is the radioactive isotope are used food preservation in the microbes. Okay, for example, you know that some things, that is potato, if we keep it as it is, then what happens? We see after some day the eyes or it shows the sprouting. Okay, and it is the sprouting. Okay, so radioactive substances is what happen. If we bombard with the radioactive substance on these potatoes, then what happens? They are not get sprouting. Next, last, the radioactive isotope, that is C14, is used to determine the age of archaeological objects. Means old objects are there. To determine its age, to determine the age of these old articles, the C14 isotope is used. So this is the about the uses of what? The isotopes. Next point is the nuclear power plant. This is our nuclear power plant. It is present in Mumbai. It is present in Mumbai, that is Bhabha Atomic Research Center. It is there. Here they are doing the researches regarding to the what? The nuclear substances. Now nuclear reactor. What is nuclear reactor? The nuclear reactor is a machine that generates electricity. Okay, nuclear reactor is a machine that generates electricity, and today I will send you its video also separately after this video. Okay, and this also, so this is generate electricity on a large scale by using atomic energy. In a nuclear reactor, the nuclear energy in an atom is released by bringing about the nuclear reaction. So what they are doing? They are doing the nuclear reaction. In that nuclear reaction, what happens? What happens? Energy is, heat is produced, and that heat we are using in the production of electricity. Let us understand the nuclear reaction with example of nuclear fuel, that is uranium 235. Okay, so here it is the reaction given, that we will see. 35 on bombardment with slow speed of neutrons. So here it is the uranium 235. When we bombard this uranium-235, this is uranium-235, bombardment means just attack, means this uranium, one neutrons is there, its attack if we done on the uranium-235, what happens, its fission is takes place. Fission means what happens here, see here, uranium on bombardment of slow speed neutron, on bombardment the slow speed neutron, the nucleus of isotope uranium-235 undergo nuclear fission, and to form the nuclei of three different elements, and those are krypton-92, beryllium-141 and 223 neutrons. Again it forms in the chemical reaction. Okay, so here we will see the chemical reaction. This is the chemical reaction. So here this is the uranium. Later. This is uranium-235. When we bombard this uranium-235 with one neutron, okay, then attack on the nucleus, and what happens, the nuclear fission takes place. If you see here, the nuclear fission takes place, and what happens, it produces two elements, that is krypton-92, here krypton-92 written here, okay, and here downside, here it is beryllium 141. These two substances are, two elements are formed. What I told you, on one atom of uranium-235, when we bombard it with the one neutron, it forms two, its nucleus fission takes place. In the nuclear fission, what happens, it produces the two elements, that is krypton-92 and beryllium-141, and with this heat is also produced. What is produced? Heat is produced, and how many neutrons it forms? The 3 neutrons it forms. Okay, this is the chemical reaction. Again this neutron is there, when it attack on another element of the uranium-235 uranium, again the nuclear fission takes place, two separate elements are formed. This is the krypton and this is the beryllium. So it is suppose beryllium, Ba beryllium, and this is beryllium, and that is one more substance, that is the krypton is formed. Now here beryllium-141 and 223 neutrons is formed. This is the reaction picture shown here in this. On decreasing the speed of this neutron, so we have to decrease the speed of neutron, then bringing the fusion of uranium-235 nucleon. In this way, what happens, on decreasing the speed of these neutrons, bringing about fission of more uranium-235 nuclei. In this way, chain of the reaction of nuclear fission takes place. I will show the video of this also. A large amount of nuclear energy is released during this chemical reaction. Here it is energy release, that sign is shown. The chain reaction is kept under control by prevent the probable explosion. Okay, so if so many neutrons are formed, what happens, again it reacts with another uranium, this will react with another uranium, this will react with another uranium, and what happens, again it forms the krypton, again it forms the beryllium and 3 neutrons. These 3 neutrons, if we show here, I will show you here. If this react with one more, what I told you, this is suppose uranium-235 uranium, again it forms the krypton and the beryllium and 3 neutrons, 1 2 3. So this is a chain reaction, again they will react with another beryllium. So see, this way what happens, it will be exploding. Okay, and so to control this reaction, what we have to do, we have to control the speed of the neutrons, and for that purpose what we are using and to control the chain reaction in the nuclear reactor, it is necessary to decrease the speed or the number of neutrons, and for that purpose following provisions are made. So which are those provisions? To reduce or to decrease the speed of neutrons, what is the moderator is used. So which is that moderator? That moderator is the graphite that is using in our pencil. Heavy water is used as a moderator. Heavy water is used as a moderator for reducing the speed of neutron. So graphite or heavy water means in which water the more number of minerals are present. This is called as a heavy water. So moderator is there. Next is the controller. To reduce the number of neutrons by absorbing them, rods of boron, cadmium, berylliums are used. So to reduce the number of neutrons, what? Boron, cadmium and beryllium rods they are using. The heat produced in the fission process is taken out by using the water coolant. Okay, so heat is this produced? No, that's heat is using for the boiling of water. Water converts into vapor, and vapors it falls on the turbines, and turbines move and the electricity generate. That is the actual process of the formation of the electricity. So here the heat produced in the fission process is taken out by using the water as a coolant. So here it is, the reaction shows the uranium.
बचपन में हम सब सोचते थे.
In this video, we're going to talk about nuclear like uranium-238 or uranium-235. The disintegration converts the uranium isotope into stable lead, and in the process emits 200 million times the energy of the neutron which triggered it. He, along with his two colleagues, Lisa Meitner and Fritz Strassmann, found that when the nucleus of uranium-235 is bombarded with neutrons, it will absorb one of the neutrons.
See, nucleus is bombarded
this results in an unstable compound nucleus, and the nucleus breaks into two equal parts. This process is referred to as nuclear fission. So, a process in which heavy nuclei are bombarded with neutrons and split into two equal masses, releasing enormous amounts of energy, is called nuclear fission. In the process, uranium-235 initially absorbs a slow-moving neutron, thus forming a highly unstable compound nucleus, uranium-236. This is what triggers the nuclear reaction. During the process of fission, uranium-236 splits into two product nuclei, which are barium-141 and krypton-92. You should notice that a barium atom has 56 protons and a krypton atom has 36 protons, which add up to the uranium atom's 92 protons. The unstable uranium-236 nucleus also releases 3 neutrons in the process. This happens because barium-141 has 141 neutrons and krypton-92 has 92 neutrons, adding up to a total of 233 neutrons. To balance the equation, uranium-236 must emit 3 more neutrons. The chemical equation of the nuclear fission reaction taking place can be represented by this equation. So as you can see from the equation, 1 neutron combines with uranium-235, forming an unstable compound nucleus, uranium-236. This unstable nucleus splits into 2 stable nuclei, barium-141 and krypton-92. In addition to these 2 nuclei, 3 neutrons are also emitted, as well as a high amount of energy, denoted in the equation by Q. Since uranium-236 emits 3 neutrons in the reaction, these neutrons can be absorbed by other uranium-235 nuclei, resulting in a chain reaction. This leads to exponentially high amounts of energy being released by a single reaction. So, in this video, we've covered that nuclear fission reactions result in massive amounts of energy being released.
Reaction is used in nuclear power plants as well as nuclear bombs. If you would like to know how uranium-235 is made, click the screen now or follow the link in the description. Uranium-235 on itself is stable. If, however, an atom of uranium-235 is hit with a neutron, it will absorb that neutron, turning into uranium-236. which is unstable and spontaneously splits into a krypton-92 and a barium-141 molecule. Those of you paying attention will notice that 92 plus 141 is only 233, not 236. The reaction will also generate 3 neutrons. This is, by the way, not the only way the uranium-236 atom can split. Consider this an example. If the uranium-235 is sufficiently pure, those 3 neutrons can and will bump into other uranium-235 atoms, creating up to 9 neutrons, which in turn can produce up to 27 neutrons. This exponential growth is what's causing the 235 to be such a dangerous substance. With each of these fusions, or rather with each split of the uranium-236 atom, an amount of energy is released. The amount of energy produced by this fission reaction is described by Albert Einstein's E equals mc squared. For more on this, click the screen now or follow the link in the description. The energy that is generated can be used to generate electricity in a nuclear power plant or to create a massive explosion by use of and I'll see you next time. The energy that is generated can...
So today we saw the uranium, how the chain reaction of the uranium and how the explosion creates the 3 neutrons and chain reaction it forms, and what is the use of this uranium nuclear fission of uranium, that is we are producing the electricity from it. So today we will stop here only, and with this video today I will send you one more video, how is the working of the atomic power plants. Okay, today we will stop here only. Okay, thank you.